Hello, this is Ivana Flores, and I'm going to present to you my final project from the physiology course. So I'll start by saying the topics we're going to cover. First, I'll explain the model, the system I chose works. I'll show you the normal functioning of the model I decided to do, as well as the pathologic functioning of the model I chose, and I'll say the goodbye. So I chose the cardiovascular system, specifically the heart, and I'll show you the normal functioning model I decided to do.
Hello, this is Ivana, and I'm gonna present to you my final project. So for my final project, I chose the cardiovascular system, specifically the heart and the arteries. This is my model. I'll explain it to you later on. So first, I'll explain what a normal functioning heart does. So the cardiovascular system distributes oxygen, hormones, nutrients, and other important substances to the cells and the organs of our body. It plays an important role in helping the body meet the demands of activity, exercise, and stress. It also helps maintain body temperature, among other things. The heart is a muscular organ which functions to pump blood throughout all our body, and it's an intricate network of blood vessels. The arteries, on the other hand, are these thick-walled blood vessels that carry oxygenated blood away from our heart. So for my project, I used a mason jar, two straws, a balloon, which is cut in half, and a little rubber band. This is the model. This is how it looks. I chose coronary artery disease, so I decided to imagine these as would be the arteries. So what happens here is that if I put some pressure here, the water that's on the bottom gets pulled up and thrown. If I push it way like harder and hard enough, it will eventually go out of the straws and will make a mess. So instead of taking it as making a mess, you could take it as it's taking the blood away. So some of the physiological concepts we can see from the heart model I showed you are elastance, which could be like an arterial elastance, flow, as in blood flow, pressure differential, which represents the force that the heart generates each time it contracts. Compliance serves to make pressure change, I believe. And surface tension, I believe it makes a form of capillary action during blood flow, during a cardiac cycle.
So that's my explanation and my model I decided to do. So as I said, the water that's on the bottom, which is inside the jar, would be taken as the blood. So each time you pump it, blood comes out of the straws, which, as I said, would be taken as the arteries. So I'll show you a image of both of the models I did. So you have on the left, my left, the normal functioning model I use, and on my right you have the pathological model I decided to do. As I said, I decided to do coronary artery disease. So I'll show you next the video of the pathologic functioning of my model.
So, as I mentioned, I chose coronary heart disease. It's a type of heart disease in which the blood arteries of the heart cannot supply enough blood, oxygenated blood to the heart. Coronary heart disease is often caused by cholesterol. A type of waxy substance builds up inside the lining of the coronary arteries, forming like a little back ball smush. This buildup can partially or completely obstruct blood flow in the large arteries, which could lead to that. I same mason jar, balloon. I put some little Play-Doh inside the straws so it can be the cholesterol builds up. So now if I push it, comparing it to the other one, it doesn't really, it's hard for it to push the liquid more. It was more easier in the other one, the clear one, than this one. So I put this image showing what I just explained. The heart, the coronary arteries, cholesterol builds up, and it does not let blood flow correctly.
So as you just saw in the video, that was my pathological functioning model. So as I said, artery disease, a coronary disease makes a buildup of cholesterol in the arteries. So as you can see in the video, I decided to put some Play-Doh, mimicking what would be the buildup of cholesterol. And you can see the comparisons in the video that it's harder for it to pump. I made a little video mashed up so you can see the differences of
It will eventually go out
one
of the straws
and the other one.
and will make a mess. It's hard for it.
So as you can see, and I'll play it again.
It will eventually go out of the straws and will make a mess. It's hard for it.
It's way easier for the blood to flow up the straws or our arteries when they're cleared than when there's buildup of cholesterol. So I hope the models show that. So for the questions, coronary artery disease. So how does coronary artery disease affect at a structural level in the physiological properties? So coronary artery disease reduces blood flow to your heart, and cholesterol plaque causes arteries to narrow, blocking blood flow. So the plaque can also burst and form a blood clot. So in what I saw and investigated, I think that one of the concepts of physiology that are very much affected in coronary artery disease is flow. So I decided to put that. Symptoms experienced by patients with coronary heart disease are chest pain, shortness of breath, fatigue, and a completely blocked coronary artery disease will cause a heart attack. So next up, we have an end of the presentation and the final project. So a big thanks to Sarah and thanks you all the Rice Community University that helped make the course. It was really fun. I actually really enjoyed it, and I hope I can get into another one soon. Thank you.